Hello guys, my name is Scholar. So in this video we're going to be talking about a project that I embarked on, which is to create a to-do list using a linked list. So this project I'll be using Python language for the implementation. So before we go on a little further into the project and what we will do, so firstly I want us to talk about something, which is the need for a to-do list. Why do we need the to-do list? So let me type to-do list. So for example, a to-do list is necessary for, let's say, for personal use, or maybe for professional organizations, just to keep track of tasks and responsibilities and prioritize work effectively. So that's basically what you may need a to-do list for. Or sometimes you might be an organization, so you need to keep tasks ready and all set so that you can go through with the tasks. So that may be for you. So the second question will be why why use linked list? So the linked list, compared to an array, the linked list can efficiently grow. It can shrink, it can accommodate as needed, for the space that is needed. It can shrink, it can grow, it can change, adapt to whatsoever we need it to do, compared to an array. Arrays may require resizing, so that's why we are using a linked list to implement it. Another thing will be a linked list allows efficient insertion and deletion at the end or at the beginning with a runtime of big O of 1, which is the time complexity of big O of 1. So that will be for adding to the front or to the back. So the next question will be how are we going to implement it? So to implement it, we will need, first, let's see the algorithm for the implementation, what exactly we need to do. So let's deal with the algorithm for the implementation. Okay, so let's say algorithm for to-do list. Alright, so the first thing that we're going to need to do is, first, for every user who is using a to-do list, the first thing will be initializing it. So you need to initialize the empty to-do list. Initialize the empty to-do list. So that would be the first step, which is we need to initialize it as an empty list. So the user must be able to receive a notification or receive to be presented with a menu. So we can say a menu with 4 options, So these options where the user is able to select one of the options based on whatsoever the user desires or what the user requires. So these options will be just to add something new to the list. So we can write the options. So we need add, which is for inserting new tasks. We need remove, we will need display to display all the tasks, and then the last one we'll need is exit for exiting after the user is done with everything else. Right, so now to move on a little further, so 3, the algorithm. So we said the user must be presented with the menu. So the menu will have 4 options, which will be add, remove, display, and exit. So the third one will be based on what the user clicked, or what the user preferred, what the user choice was. from there on we can move on to the next. So say for example, if the user chose add, so according to that choice we set task description from the user. So we need to get the task description from the user. So the user will provide us with the task description, and then when the user writes the task description, from that task description, from that task description we can able to append it, to the to-do list. So get the task description from the user, task description from the user, and append it to the list. So that will be our algorithm number 4. All right. Then after getting the task description from the user and appending it to the list, that will be for add, for implementing the add function. And then if we go to remove, we get the task description from the user first, so that we may know which task is to be removed. And then that task which is described by the user, we find it by traversing through, and then we delete it. So that will be for remove. And then the third one was display. So display will be to display or to show all the task descriptions that are available on the list. All right. And then the last one will be exit. So exit will be for ending the program or quitting the program. And then the fourth one algorithm will be to repeat steps 2 to 3 until the user decides to exit. Until the user decides to exit. All right. So this will be the algorithm. This is what we want to do. This is what we want to implement for the to-do list, so that the user is able to, an interface which will be user friendly, and the user is able to interact with it, and for efficient movement, and allowing the insertion, deletion for the to-do list. All right. So now we'll go on to the fourth step, which is how are we going to implement it? How exactly are we going to implement it? How exactly are we going to implement it? So since we said we will be implementing it using what is called the linked list, so in this case I'll be using a singly linked list, because linked list has double linked list, single linked list, and other linked list. So in this video I'll be implementing using the single linked list. All right. So let's see how the implementation will go. All right. So for a linked list, try get something. For a linked list, what we usually have is the first element, which will be the head. All right. So we usually have the head. Let me try and shrink the size for the implementation. All right. So we usually have the head. Okay. Let's see what can be done. So we usually have the head. All right. So this head is usually pointing towards something. So this head will be pointing towards something. That's so in this case this head will be pointing us towards our first task, which will be task 1. All right. So this head is pointing towards our task 1, and then this portion in every linked list, so we have the node, right? So in every node there is the data, and then there is the next. So the next part is the part that contains the pointer to the next element or to the next task that is there in our case. So we have the head, which is pointing towards the task 1, which is our first node, right? And then this task 1 will also have what? A next. All right, so this task 1 will also have a next. So this, let's consider this to be our next. Let's do this. All right. Right. So this will be containing our next. So this our next is what will be containing the reference, or should I say the pointer, to the next task, which will be our task 2. So here, over here, that's where we have our task 2. All right, so this our task 2 will also have its next. All right, so if this next is pointing towards task 2, all right, then that means that whatever, when we are accessing it, this pointer will point us to the next task. All right, so that is clear. And then task 2, if it is the last task, it will have, you know, its pointer, which is its next. It will have its pointer, which is its next. Let's insert it there. So its next. All right, its next, this next of this pointer will be pointing towards now. All right, towards now. So let's insert this one. Yeah, the line 1, and it's next pointing to now. So let's place its next here. So it's next, okay, will be pointing to now. All right, so this will be meaning it's the end of the list, the linked list. So since its next will be pointing to now, so this also happens to be its next. So let's insert it there. Disconnect. Right, so this is the next also, that will be also pointing to now. So this next now, which is this part, is also pointing to now. So we said it will have 2 parts. Every node will have 2 parts, which will be the part of the data where we said we'll put the description of the task 1, or the description of whichever task it is, and then it will also have its next. So when its next now points to now, that means it's the end of the linked list. All right. Right, so now what will happen is, when we are making this linked list, we are making the to-do list. First of all, we initialize the empty to-do list, and then we will have to add tasks to that empty to-do list. So in our Python implementation, that's when we'll begin to see how we'll begin to create nodes, because we need to create nodes, and then we need a function also that will be adding tasks. So in adding tasks, the pointer head will be set to the task that we are adding. So now when the pointer is set to the task that we are adding, then that task gets added, and then the next of that task that has been added gets pointed to now. If we are to add another task, then we create that node. After creating that node, the next of the previous task gets set to point to the task 2, and so on and so on, until the last task, which its next will point to now. So in implementing the removing function, say for example we want to remove task 1. If we want to remove task, let's say task 2, we want to remove task 2. If we want to remove task 2, then we will have to have the next, which is the pointer of the next pointing to null. Instead of it pointing, the next pointing to task 2, we will have this pointer, this particular pointer, pointing to null. Alright, so we have this pointer, this particular one, removed, and then we will have a different pointer which will be, pointing to null. Alright, let's make it a little pretty. Alright, so once this particular pointer of this task, which is the next, once the pointer points to null, automatically this task is removed from here and gets removed from the list. So that's how we'll be implementing the removal function. And then we have the display function, which will traverse through all the list and display everything that is in the list, in the linked list. And then we have the exit, which will be exiting the list. So without wasting much of the time, let's go to the implementation. So we'll be in VS Code and we implement the to-do list in Python. Alright guys, so now we're in VS Code. So the first thing we want to do is to create the class task. So class, we'll call it task. Alright, so this class task, and then we need def to define we'll pass self and description. Alright, so pass self and description of the task. Self dot description is equals to description. Right, and then we also need self dot next, as we were using it, so that will be for data. And then now we need self dot next. So here we are creating the node for the task. For creating new node, we'll be calling the class task. So for now we set the self.next to none, since the linked list is empty. Alright, so this will be for creating our node. Alright, so next up we will create the to-do list now. So we'll be using, let's use class to-do list. Alright, so need to define terms, def init, we'll pass self, and then we initialize self.head to none. Right, so self.head is pointed to none for now, since it's still empty, there is none. Alright, so that's initializing as we are going with the algorithm. Now we want to create the function for adding task. So create the function add task. So this function add task will be responsible for adding new tasks. Right, so for this function what we will need is we will need to pass self, and we will also need to pass description, right, so that we get the description of the task which needs to be added. So we pass self, and then we will pass description. Right, so we pass self, pass description. Right, so having done that, we now go into the function to creating the new task. So new task will be equals to, we call the node task, and then we pass description. So the description which we'll get from the user pass. So then we create the new node, which will be our new task, right? So we would have created our new node. All right. So now we need to handle a few instances. For example, if we need to know if the linked list is empty, we need to know if the linked list is not empty or there's already a task inside, right? So for that, we are going to have to create an if block. So to check if it's self-head, I say if not self.head, right? If not self.head, then self.head, we set it to the new task, right? Equals to our new task. All right. So if not self.head, then we need to set that self.head the new task, so the pointer gets to point to the new task, right? Right. So we've handled the first condition. So the second one, we have the else block. Else, right, we need now to say, okay, to counter for other options, for other place that will be there. So typing error, else. So we have the else block there, else. Now we'll call this one current. All right, so the current one, we set it to self.head. So okay, the current, let it be equals to self.head, self.head. All right, so now we know that we've set this current to the self.head. Now we want to loop through so that we can find a pointer that will be adding the new task where it is now. All right, so when we get there, so that we can add it to maybe the next to that task. For example, if we've already added task 1, right? So we'll say while current dot next, that would be for looping. Current is equals to current dot next. All right, first stage. Then now the current dot next, which is the next of that self dot head, should be set to the new task. So current dot next is equals to our new task, right? So now he has managed to add the task. So this will be the function for adding the task. So having done that, we might need a message to tell us that the task has been added successfully, or there's some faults or some errors that have happened, in adding the task. So what we'll do is we'll put a message, so print. All right, so what we'll do is we'll place a message, and then we say task. All right, and then we'll put that task, and then we'll call it description. Perfect. So for the task name, edit. So I think that's perfect. So that will be the function for adding the task. So now to get to the removal, create the function to remove. So def remove task. So pass self. So we take two arguments, self and description, to describe the task that we want to remove so that we can search for that task, right? Indentation error. Right. Perfect. Right. So now we'll traverse to say, okay, if there is nothing, then if not self dot head, then what we establish is that the linked list is empty. So what we want to do is we want to print, because we want to get that message, the list is empty, so meaning there is nothing to delete, right? Right. So print the list is empty and then return. Right. So that's the first condition that we have managed to deal with. Now we move on to the next one. Right. Now if we want to check now for the description, so if self dot head dot description is equal to description, which is it matches the description which we have given, which the user of the to-do list has given, then what that means is we now traverse through it. So self dot head, we set it to self dot head dot next, right? Now after that we want a message to tell us that the task that we were searching for has been removed. So we have set the self.head to the self.head next, meaning we are removing that task which we have found of the description. All right, so that's to say if it's at the first. All right. Right. So now we want a message to inform the user. Right. So what we will do is, let me do this. What we will do is we need to inform the user the task that has been removed. Right. So we'll put description. So that will be the task with its description. So we'll tell the user that this task has been removed, right? So we've removed that task, right? Now we want to check another condition, right? So here we forgot to return right. So now we have gone through that. So now for another condition, so we say current is equal to self dot head, right? Now we want to loop through so that we can find the description that needs to be removed, just in case it's not the one that is being pointed by the self dot head. All right, so current is equal to self dot head. Now we say while current dot next So while current.next if current dot next dot description is equal to description, then we have found our description that we wanted. So what we do is current dot next, we set it to current dot next dot next, right? So that's us removing this description that we have found for the current dot next dot description is equal description, set the current dot next to current dot next dot next. All right, so now we want a message from the user, so we want to print that message from the user, for the user to tell the user that okay, the task has been removed, right? So the same thing, forward to add quotes. So we'll remove description, removed. Right. Then now we have done that, so we return. Okay, so now we say current is equals to current dot next. All right, so now if all the conditions fail and the user has not provided us, or has not provided the system with the proper message, then we'll print the message task, and then we'll print the description of that task that it's not there. All right, description not found. Right, so that goes for the removal of the task that we would have inserted. Right, now we want to create another function for the displaying, which we said we'll create. So we create a function for displaying task, displaying all the tasks in the list. Right, so pass self, all right, so also we'll check if not self dot head, then we'll print that there is nothing, the list is empty, there is nothing to see here, the list is empty. Right, so if not self dot head, right, and then we will return to get the return. Right, then if not self dot head, so we've seen that we'll print the list is empty. Now the else part of the condition, so what we will do is we want to print what? The to-do list. So what we'll do is create a new line where we will be printing the to-do list. So new line, the title to-do list, and then we will have to go through it so that we can process the descriptions that are there and we display them in a systematic way. All right, so now we will set our current, so where our pointer is right now, we'll set it to self dot head. All right, then we set our index, which we'll use to loop through. Our index, we set it to 1. All right, and then we say while current print. What do we want to print? We want to print the index and then the description, okay, so that we can have the numbers for the list where we have 1, we have 2, we have 3, like 1 go to the grocery, 2 go get this and all that, right? Right, so f index current dot description. All right, now we need current to be set so that we can loop through the current, so it will be current is equals to current dot next, and then same applies for the index. You need it to be incremented as we loop through, as we enter into this phase, okay, equals 1. And then while we're done with that, print. Right, so we are done here. That's for display task. Now I want us to create to simulate the view so that we can have the perfect view. So we'll create a main where it will display all the tasks and it will display the view to be much more better. The to-do list, to show the to-do list at the top, then it will present the options to the user. All right, so let's create the def for main. Right, so we say to-do list equals to to-do list. Perfect. Right, so calling it there, and then we say while true, I want to show the options for the user. Say print, so we need to print it in new line, options to be written as options for the user, options, and then from there on, alright, let's put a semicolon for the options, and then we'll begin to print all the options that are there. Right, so let me do this. Print 1 will represent a task, so let's copy that. Okay, so paste that. so we need 4. This will be for 2. This one will be for remove task, and then option 3 will be for display task. This will be our option 4, which will be for exiting. Alright, so now we want to create the menu so that, you know, based on the choice of the user, we are able to, you know, print some messages, show and view all tasks. Alright, so we initialize choice of the user. The choice is equals to, we take the input from the user, input, and then we give the user something, choose an option from 1 to 4. Right, so now we say if choice equals to 1, so that means the user has chosen to add task, and then task is equals to input, so we need to ask the user for the description, enter the task to add. Alright, and then so enter the task to add, so this will take it, and then what we will do is we will call the to-do list function dot, then we append to it, so we take it to add task, right? Now that will be for choice 1. Now we say elif choice equals to 2, elif choice equal to 2, so let's pass it as a string, do the same thing there. It was going to give us an error. Alright, perfect. So same thing, but now we do it for remove. So still we want to get the input from the user, whichever description of the task that they want to remove. So we say enter the task to remove. Right, now which function will we call? We call the to-do list, and then under that to-do list we'll call the remove task. Alright, so that's our function call. Which one? The task that we just asked for. So the same should apply for that one, because we did not add any task. So that task which we got from the user. Yeah, now it seems alright. Now elif choice equals to 3, so if choice equals to 3, we now need to display. Alright, so what we will do is to call the to-do list and then dot display task. Perfect. So this one will show all tasks. Alright, then now elif choice equals to 4. Alright, so 4 will be for exiting. So what we will do is to print a good message to tell the user that alright, we are exiting the program. Bye, exiting the program. Then we'll say bye. Alright, yeah, sounds good. And then break so that it doesn't loop. Alright, and then so now we've broken out of it, and now we have the final block, which will be our else block, meaning the user would have entered anything other than the required, which is the range 1 to 4. So for anything else to counter those errors, so what we'll do is we'll print a message to tell the user invalid choice, and maybe say please try again, please try again. Perfect. Alright, so now we're done with the program. Let's make it to run. So say if name, that one, equal to main so if name equals to main, main, perfect. So if name equals to main, then we'll call that main. Right, so there goes our program for it. So let's run it. Let's run the code. Alright, so now we are provided with the options. Choose option, says options, add task, remove task, display task, exit. So put one to add a task, enter the task to add, go to the market. Alright, so it says task, go to the market, added. Alright, say now we want to add again, and then enter the task to add, buy bread. See here, task buy bread added. Okay, now the remove function, let's check the remove function. So let's remove buy bread. So task buy bread removed, you can see here, task buy bread removed. Okay, so now let's see the display task. So there is only one that we had added, which is go to the market, and then if the user clicks for exit, so exiting program, so it has exited the program. So that's it for this video, guys.